It's a very good topic and then very important topic, very interesting topic. Okay, so many history and interesting stories are discussed over here. We'll discuss about this in a brief manner in a later days. Okay, first we'll see the topic, okay, which is relevant for your exam, and then especially for your boards and then JEE mains, NEET and all. Okay, so you know that this Galileo, a nobleman called, so during the period of Galileo means Galileo's period, it is given here. First Ptolemy come and then Galileo came. So this is the famous physicist Galileo's period. What is the period, Sauji? What is the period?
1664 to 1642.
Yeah, basically 500 years before, right, Ma? So Galileo, during the period of Galileo itself, there is a nobleman called Brahe. See what he is doing actually. He was doing always, he was just visiting some places, calm places, and then he looked upon some high places also he went, and he observed so many things on a sky through his naked eye. On those days, there were no inventions of any telescopes or any observatory. Okay, only he can see, he can observe what are all the things in the sky with his naked eye. And then he compiled so many data based on that. Daily he was watching a group of stars and then some planet and then some changes in the observation. So, and then he compiled the data. Okay, and then later his data were analyzed by his assistant Kepler. Johannes Kepler was the scientist. He was the assistant of Brahe. He could get attracted from his particular, observations. Okay, his data, what all he observed from the sky, and then that gives him a very good idea about, what is about the planets. So what is the solar system, and he only just suggest what is meant by gravitation, and then he just proposed so many laws. Based on that, he created a universal law for gravitation. Get my point? Okay, is it clear?
Yes, ma'am. Yes, ma'am.
So this is very important point. So he get attracted towards that observation only. This Brahe did something that was get attracted by this Kepler, and then he used his brain to compile so many laws. Okay, so what is the first law? Kepler's laws. This is very important topic. You must better understand this. Out of it, you'll be getting more questions from your CBSE as well as your JEE or something. What are three laws of Kepler? So first law is law of orbits. You know that all planets move in elliptical orbits with the sun situated at one of the foci. So that was found after Sommerfeld stated that the atom, electrons in an atom are revolving around the nucleus in an elliptical orbit. Sommerfeld only created that. Right. On those days, it becomes a very famous thing. So after Einstein, Bohr suggested the circular orbits. Bohr was predicting that it was a circular orbits, but Sommerfeld only, just correct it, and then he said, what is that? It is an elliptical orbit. Okay. Suppose if it is in circular orbit, then what will happen? Sauji, see, for example, if it is a circular orbit, which one? Our solar system. So here is the sun. Okay. Planets are revolving around see, for example, we are considering only Earth. Earth is revolving around the sun. Okay. Then what will happen? The distance between the sun towards each and every points on a circular orbits are same. So that if the temperature, within this distance, the temperature of the sun we are receiving is 45 degrees Celsius. The same 45 degrees Celsius will be received. This is, for example, March month. The same for April month also. The same for May month. The same for June. Same for, December also, right?
Yes, ma'am.
If it is in circular orbit. So that the people think about all these things. We are getting seasons, right? We are not getting always same temperature. The temperature received from the sunlight is differing. We are getting hot days and then cold days and then moderate climate, everything. Is it clear for you? So that only they have assumed the orbit should be definitely elliptical orbit. So ellipse has, what is the property of an ellipse? It has its own center. It has its own center. Okay. And then the sun is at one foci. So there are two foci of the ellipse. So here, this is, foci means the plural of focus. What is focus? The ellipse contain, see, for example, the ellipse contain major axis and then minor axis. Where the major and minor axis cuts will give you the
origin.
Yeah, that is the center. Okay, baby. The origin must be the center of the elliptical orbit or center of the ellipse. Okay, the center means it consists of, from it we can say it is semi-major axis. In your book, it is denoted as A, and then it is minor axis is B. So that 2A is semi-major axis, sorry, major axis, 2B is minor axis. Understood? And then this is said to be the focus. This is one focus, this is another focus. So what is it? Left side focus.
Half of it.
Focus, what is meant by focus? Focus is exactly the halfway between the edge of this particular point and the center of this ellipse. Okay, halfway. We couldn't say it is exactly middle. It is halfway between. Understood? Based on the circumference, it might be varying. This focus must be varying. So if you are considering one of the foci, then where the sun is presented, for example, you are taking. Okay, then what will happen if our planet is here? It is very near to the sun. If it is here, it is very near. Understood? So that here and all, you'll be getting peak summer. In the opposite manner, this A is known as actually very farther to this particular thing, right? This A is. So since it is very farther from the sun, the temperature is little bit reduced, and then we get colder temperature. Didn't get more sun, so it is very chill and cold. Is it clear for you? Hello?
Yes, ma'am.
So in between there is moderate climate, so that we are getting seasons. What are all the seasons? Summer, winter. Summer and winter are opposite together. So what is the summer position? Summer position is known as actually here perihelion. Where is the point? It is given in your book. It is known as perihelion. Okay, see here. Okay, the closest point is perihelion. Understood? Helion represents the sun's orbit. Okay, perihelion means, what is this perihelion? It is the closest approach of the sun, closest distance from the sun. The earth is now at the closest distance from the sun. If it is farthest distance from the sun, then what it will be? Aphelion. Okay, so this is aphelion. A is the aphelion. Is it clear for you?
Yes, ma'am.
This shows the law of orbits, and then here it gives you an idea of how to perform this ellipse, how to draw this elliptical orbit. Okay, so how to draw this elliptical orbit? It is given in that drawing an ellipse, right? A string has its ends fixed at F1 and F2. Understood? These two are, this is the string. Okay, initially a string is here, and then you are just dragging this string to this particular point, for example, and then trying to draw a circular path or circular thing. If you try to draw like this, then it forms an ellipse. You are having protractor to draw a circle. How can you draw this ellipse? Using the spring. Understood? So
Okay, ma'am.
the pencil has to hold this string taut, and it is moved around. Then you'll be getting this elliptical orbit. So you can try at home all these things. Okay, if you get any elastic spring kind of thing, a thread of that, okay, you'll be given. You'll be getting this elliptical thing. Okay. Nowadays, there is no need of all these things. You'll be having all the tech, right? User-friendly tech. Then you can able to draw an ellipse in an easy manner. Okay, you just go through it. It is given in a detailed manner for drawing an ellipse. Okay, so that it should be pakka and permanent. Understood?
Okay, ma'am.
Okay, then you know about what is semi-major axis, semi-minor axis, then how the seasons occur. Everything you know, right? So this is
Yes,
law of
ma'am.
orbits. First one, law of orbits. Just keep in your mind. Next one, law of areas. Law of areas means, you know that here it is very shortest distance to the sun. So here, see, the law of areas, it said, okay, the sun sweeps equal areas in equal intervals of time. Any planet, okay, to the sun, it sweeps equal areas in equal intervals of time. What is the meaning of that? For example, a planet P is coming from this place to this place, which is very closest to the sun. In this particular time, it takes so much of time. The time period move from this point to this point, it takes much time when compared to the farthest distance. In the farthest distance, the earth moves very faster. The time period is less. Yeah, this is actually a very big thing. It was observed by Kepler. Very big thing. You can raise your questions in an open way, Arian. Okay. So very big observations. It was done on that day. So Kepler has we had to admit Kepler was a very great scientist and brainy too, right? So he observed all the data and then he was saying, so unless otherwise, it won't be like that. Okay, what is the story actually? What is the story behind this? The area swept by the planet, okay, each and everything, okay, the line that joins any planet to the sun sweeps equal areas in equal interval of time. What is the meaning? Suppose if you join this line like this, then the area in this particular thing is equal to the area in this particular thing. Okay, so how it is possible actually? It is possible only by the movement of a planet. Unless otherwise it won't. If the planet is moving around the elliptical orbit in a constant speed, or we may say if it takes regular time, okay, constant time period or constant speed, then what will happen? What will happen? Definitely, it won't actually form in an orbit. There is some deviation. That and all you are going to learn in next year. Okay, class 12.
So it can go like so fast?
Yeah, actually, wherever it goes faster, wherever it goes slower, that and all has to be observed. So what is the point here? What is velocity right now? What is velocity? Rate of change of displacement. Very good. So what is velocity, Sauji?
Displacement by time.
Yeah, rate of change of displacement. Okay, not simply displacement by time. So what is rate of change of displacement? The planet is moving from one point to another point. Understood, ma'am? So this is its displacement, change in displacement, right? So if the planet is revolving, if the planet is moving from one point to another point, definitely it takes some time. So with this particular regular time period, that is velocity. Is it clear? What about this distance? So the distance nearest to the sun is greater. So the velocity also greater. The distance nearest, farthest to the sun is slower, right? Farthest to the sun is, what is that? The displacement, I'm saying. Displacement is little much, low, or we may say little much smaller. Okay, then what we can say, the velocity will be higher. How it is possible? Because the time
Because
period is...
P dash and P, the straight line is like very small compared to that side. So
No, dear, we had to look upon with the speed only, velocity only. Okay, so the planet appeared to move slower or appeared to move nearer. Appear to move great. What is that? Okay, only one thing is given. Okay, the planets appear to move slower, or what is the vice versa? The planet appears to move faster. So these things has to be done. Where the planets appear to move slower?
when the displacement is small.
Very good. When the displacement is small. Why the displacement is small? It is farthest from the sun. Understood, ma'am?
Yes, ma'am.
Okay. If the planet is very much farthest from the sun, then how it shows, ma'am? The displacement is very low, very smaller. That's what I'm just trying to explain. Okay. So what is this displacement? The displacement of this planet is very much slower. Okay. So if it is slower, then the velocity will be slow. Yeah. What is the velocity? Velocity is directly proportional to the change in displacement.
Oh, okay.
If the displacement is very small, then velocity also slower. If the displacement is very big, then the velocity also big. Get my point? Okay. With this idea only, he just able to create some gravitation between these two, some force of attraction between these two. What he is admitting, the force of attraction between the sun and the nearest points are very much higher when compared to the furthest distance. What is the meaning? During summer days, the planet moves what? Very much faster during summer days because it is very near to the sun. So the gravity also greater. It has to see. Suppose if you are pulled by anyone, but you want to move. If you are pulled by anyone, you are just pulled up by anyone. No, you are just making yourself to move faster, right? Then only you can able to move further.
If the Earth is far away, it will go.
Yeah, the Earth is far away from the sun means it is cold. Far away from the sun means it experiences less force of attraction of the sun. So it may move very slow. Yeah. Is it clear for you, Ma?
Yeah.
So here comes
Yes,
the
ma'am.
idea. Here comes the idea for him about the gravitation. Okay, for the gravitation, for understanding gravitation, Kepler's just derived all these laws. So always I'm just insisting my children to know from the scientist perception. Okay, what is his perception right now? You got it, right? So
Yes,
he
ma'am.
derived all the laws by observing the data compiled by Brahe, and then he get this idea, and then he derived a law, which is universal law of gravitation, based on these three laws. Get my point? With that data, he created everything. So it's a very good procedure he did. You must know from his perspective. Okay, what is his perspective? His perspective is he knows the planet is line up with the sun in equal areas. It sweeps equal areas in equal interval of time. So that is his law. It states. So in his mind, in his viewpoint, okay, what he says, during summer, the earth is moving little bit faster. During winter, the earth is moving little bit slower. That's what it is managing. But still, what is the calendar? Calendar shows the biggest time period. That is the day, month, and then year. Understood? So it is a very big thing. So what is the time actually? Minimum time is second. So from second to minute to hour to day to week to month and to year. Understood, ma'am? So and then era. Like that it will be coming. Yeah, decades. Yeah, decades, era. Era means it is 100 years. Like decade means 10 years. So what I'm trying to say, this and all, the measurement of time, we are just keeping it. So that Julius Caesar period, he just segregate all these things on those days. Yeah, I will tell you that. On those days itself, before Kepler. So Kepler got so many ideas actually from the people also. Okay, see, this kind of attitude you should have. Then only you can perform very good in your career also. Understood? In your education as well as in your career. Kepler was a disciplined student, it seems. It shows all his data and observations. Understood? He observed everything and then he knows about all these things, right? So Julius Caesar, he just created a month, 30 days, 31 days, 30 days, 31 days, like that. Okay, so he's already conveyed like each and everything sweeps out in equal area, in equal intervals of time. So he has created a month as an equal interval of time. Understood? Say, for example, this is what month? I mean, this is actually March, we can say. This is March, means this one is December. Really interesting, no? Yeah, but it also consists of, 31 days or something. It also consists of 31 days. But the sun has to travel this much of distance. See, the length of an arc, it is very big when compared to this, right? Okay, then how it takes only 30 days means it has to move faster. Unless otherwise it can't. I think this will give you a very good idea what Kepler had on those days during 15th to 16th century. You get an idea right now. Now we are getting into Kepler's mind. Okay? Get my point, all of you?
Yes, ma'am.
Okay, so then we'll see law of periods. It's very interesting. So what is law of periods? The square of the time period of revolution of a planet is proportional to the cube of the semi-major axis of the ellipse traced out by the planet. What they said, the square of the time period of revolution of a planet. If a planet is revolving around an elliptical orbit, so that is said to be one completion, right? 1 year for an Earth we are saying. Okay, 365 days is calculated as 1 year. For our reference, we are calculating. And then this is a complete one revolution. Get my point? So that is considered as the that is designated by letter capital T. The square of this particular T will be proportional to what is the semi-major axis we have considered here. It is designated as A. Total major axis will be 2A. So semi-major axis is half of 2A, that is A. What is semi-minor axis?
That's
B. So what they said, what is the law of periods? The square of the time period of revolution of a planet is proportional to the cube of the semi-major axis of the ellipse. That is traced out by the planet. Individual, it may vary. Planet to planet, it may vary. Understood? Get my point? Hello, Papa? Hello? Are you
Yes,
there?
ma'am.
Okay. So this table, it demonstrates the time periods of revolution of 8 planets around the sun. Why it is 8 planet? What about Pluto?
Pluto is a
Dwarf planet. Okay, it's not planet. Yeah. Okay. So what they said, T square is directly proportional to AQ. So if it is directly proportional in physics laws or mathematical approach, we can say what we can say, it is equal to some constant. Constant into AQ. Understood? What is T square by A cube? That is equal to some constant, right? You can bring it. Okay. So t square by a cube is equal to constant. That constant is known as quotient here. Okay. Clear, Papa?
Yes.
Okay. Okay, Aryan. Savji?
Okay, ma'am.
Okay. What is this? Earth time period is considered as 1 now. Time period is 1. What is this? A semi-major of the Earth, semi-major axis of the Earth is 15, 10 per 10 meter.
Oh,
Not a simple thing. What is 10 per 10? Can you freeze it like in kilometer? See, for example, 15, this kind of thing also you must know from this, how to solve numerically everything. Okay. So what is this 15 meter? Sorry, 15 into 10 per 10 meter. It is known as 10 per 10 meter is angstrom unit. What is 10 per 10 meter? Angstrom unit. So you can consider 15 into 10 per 3 into 10 per 7 meter. Can you consider like this?
Yes, ma'am.
Or 10 can be written as 7 and 3. If you add 7 plus 3, it will be 10. So what is 10 per 3 meter? It is kilometer. 1 kilometer is equal to 10 per 3 meter. Okay, so what is this 15? And we have to add how many zeros? 7 zeros. If you add 7 zeros, how much it is?
that's one. I don't know. It's 15 million. 15
Billion.
million.
Okay, or 15 crores, we can say. 15 crores kilometer. Okay, see, for example, what it says, average. This is an average, right? Since it's an ellipse, so you'll be seeing, sun is here. Sun is here. Okay, Earth is revolving around the sun in various periods, like periods means this distance is varying. So if you take an average of all these distances, it's not radially, we cannot able to radially represent the constant distance. It is radially varying. It is radially varying. Yes, Aryan?
One doubt.
Yeah.
So here, the closest to the sun is summer.
Yeah.
And how it takes like 26 months to finish summer.
Yeah,
And then
almost.
around 2 months, 4 months to finish summer.
Yeah, like that.
So
Okay,
one doubt,
like that.
But if the winter, it goes slowly. So how can it finish in 4 months? How can it finish in 4 months?
No, actually, that is the case. It may move very slower when it is farthest from the sun. When it is closest to the sun, it has to move very faster. Okay, unless otherwise it can't complete its orbit in a particular days. Okay, so suppose if radially varying, what is when the radially varying? This distance is not exactly same, right, Savji? This is different. This is different. This is different. Different. Take an average fully. Then you'll be getting approximately 15 crores kilometer. So from the sun to our earth is what is the distance? I mean, radial distance. 15 crores, 15 billion kilometers. Yeah. Is it clear, ma? Hello? Hello, Sauji.
Ma'am.
Clear for you?
Yes, ma'am.
So it is actually really, really great thing. Actually, the man or scientist, they just found everything, right? Is it clear? It is an approximate only, but we can able to assume everything and then we can able to calculate by means of mathematical methods, right? So math is, as I've told you, since physics is a king of science, math is a queen of science. Unless otherwise we can't do anything. Okay. So when compared to this, so it is Earth's data. This is Earth's data. So when compared to this, what about Mercury? Mercury is 0.24 of Earth's complete revolution. Suppose if you want to calculate in Earth days, you have to say like that. Earth days. Earth days are not same for Mercury days.
Mercury is the first planet.
Yeah, Mercury is very near to the Earth, Sun. Right. So 0.24 of Earth days. Earth year. So what is Earth year? You can say 365, right?
Yeah.
So what is 24 by 100 into 365? Do calculate. Sauji. Do calculate. Make it fast. Sauji, are you doing? Sauji? Hello? Are you there?
Yes, ma'am. Doing.
It will be around 87.6. Or we can say 88 days. Within 88 years.
Yes, ma'am. 87.6.
Yes, dear. Within 88 Earth days, the Mercury revolve around the sun. So when you suppose imagine when you are in Mercury, then what is your age? So 365 divided by 88. What is that? Huh? 4. right? Almost.
84.
No, for 1 year of Earth, you are considered to be 4 years in Mercury. Okay, then 12 times of 4 means 48 years you are in. Okay, understood, Sauji? Years ages 16 times 4, 64 years, right? Sauji? Hello? Will you be there?
Yes, ma'am.
Is it interesting?
Yes, ma'am.
Yeah. So likewise, you have to imagine everything and then you should correlate with this idea. Okay. Then what about this? We'll consider Uranus. See, Uranus is very far. So it's what is this? Its semi-major axis is 287 angstrom unit. Unimaginable, right? 287 angstrom unit means it is very far. Okay, so what is its time period? It says 84 times the Earth's. Okay, if you multiply 84 into Earth year or Earth days, 365, what is that? 30,660 it is coming. Yeah. So what is 30,660? It is 84 times.
Yeah.
Okay, understood. So Earth year and this year is comparably very greater. Okay, understood.
Yeah.
So how many days it is having? 30,660 days, Earth days. It should contain to revolve around the sun. Understood? Then 1 year in, suppose 84 years in Earth is considered to be 1 year in Uranus.
Only 1 year.